Much for having me. And I think this will be, a fun, insightful, informative webinar here, giving you a little insight into wavefront guided scleral lenses and how we can use these devices to reduce higher order aberrations, but also induce higher order aberrations. So this will be kind of a fun lecture to get through. So I'm John Gelles. I'm the director of the Specialty Contact Lens Division at the Cornea and Laser Eye Institute and the CLEI Center for Keratoconus here in Teaneck, New Jersey. Um, I have a few disclosures, work with a few companies, mostly in a research and consulting capacity. So kind of a fun thing to start off with when you're giving a lecture on higher order aberrations is to, demonstrate higher order aberrations to the individuals who are attending the lecture. So what you're seeing here is a perfectly black background with a perfect white spot in the center. And what I want you to do is take a look at that white spot. And what you'll notice is that it's not a perfectly round white spot. What you'll see is that there's a little bit of fuzz or blur kind of around the edges of that. And that is higher order aberration. And if you cover one eye and then switch and cover the other eye, what you'll notice is the aberration is not exactly the same between each eye. You have slight differences there, and that's because we are human. The only way that you are going to see a perfectly white dot on a perfect black background there is in a simulation. With any sort of lens or any eye, there's going to be some level of aberration present. Now, if you have a normal eye, you may see something like if you have some astigmatism or even some coma, you may see a directional streak. If you see kind of this, you may actually have keratoconus. What you're seeing is a large deformation of that spot. Now, what we just reviewed for you is something called a point spread function. And this is a really good way to kind of simulate higher order aberrations. What you can see here is there are various different types of quantifications. And what you can see here is that we can quantify the different types of aberrations based on the pattern. So we quantify these in these Zernike polynomials. So if you combined different types of aberration, those different patterns of aberration, you get these sorts of, images here. So nobody's ever going to have purely trefoil or purely coma. It's always kind of a combination of a variety of aberrations that end up with a image like this. What we have, though, is we can split these aberrations into higher and lower orders. The lower orders, like what you see in the left, defocus and astigmatism, those can be corrected with glasses. So you can kind of imagine defocus is going to be either your myopia or hyperopia, which is going to be corrected with concave or convex lenses, and your astigmatism, which obviously can be corrected with cylindrical lenses. When you get into higher order aberrations really cannot be corrected with traditional optics like what you have in glasses. So these are going to be things like spherical aberration, coma, and trefoil. Patients may describe these to you as halos, starbursts, or flare or glare coming off of images. So when we look at these are going to be the things that really contribute to the quality of vision for an individual. When they say, hey, I can read the 20/20 line, but it's just not clear, this is what is reducing that quality of vision. So I really love this one. This one's from Jason Marsack, which was basically saying, are letters on a chart a good method of evaluating clarity of vision? So what you can see here is we took a letter E, which is got no higher order aberrations in it. You can see that in the center. And what we did going from left to right is start progressively adding more and more horizontal coma. And what you can see is as we start to increase the amount of excuse me, horizontal coma, you can still see that this is clearly a letter E, but you can see how the quality is getting reduced as we add more and more of that aberration. So what we're really demonstrating here is that clarity of vision is what patients really are after. They don't just want to be able to see the letter, they want to see it crisply. So, what do we need to know also about aberrations? Well, aberrations are variable. Excuse me, just getting over a cold here. So, aberrations are variable. So, they are going to vary based on the pupil size, and they're also going to be variable based on the age of the individual. So, as a pupil gets larger, aberrations are going to increase. As an individual gets older, they're also going to increase. So what we can see here is that basically as we're getting a smaller and smaller pupil, what we're getting is more and more of a pinhole effect. As we're getting a larger and larger pupil, what we're getting is more spreading of light coming from those peripheral corneal rays, right? So, what we can use to quantify the amount of aberrations that an individual has is by using a device called a wavefront aberrometer. And specifically, the one that we're going to go through today is something called a Shack-Hartman. Now, there are a variety of different aberrometers out there, from shearing to ray tracing, but this will be what we focus on today as the technology. So basically, the way that this aberrometer works is it's going to work by projecting light into the eye. And what we're going to look at is how the light reflects back out of the eye through all the optical system of the eye and back into the device. So imagine the eye as an optical system. What we have are the front of the lens, or excuse me, the front of the cornea, the back of the cornea, the front of the lens, the back of the lens. All of these are going to be the optical structures of the eye. So what we're doing is we're watching how that light that is projected into the eye reflects back out through all of those structures. And what happens is that reflected wavefront then hits a micro lenslet array. So imagine each one of these lenslets are evenly spaced and they all have the same level of focus, right? So what's happening is as that reflected wavefront goes through this micro lenslet array, what we're getting are these individual points of focus that are created and end up falling onto a wavefront sensor. And what we're looking at is the clarity of each point here. And what each one of those points is going to correspond to is a different point of light that's coming through a different portion across that pupil, right? So what we're looking at is the clarity of vision of that individual at any point across their pupil and that point of clarity there. So to kind of give you an idea of this, on the left is an individual with a normal eye. On the right is an individual with keratoconus. Now, the thing about a wavefront aberrometer is that it can't differentiate a normal cornea from an abnormal cornea. All it can do is tell you that there is deformation or irregularity of the focus uh, across the pupil coming from any of those ocular structures, right? And if you're wearing a contact lens, the contact lens just becomes part of the optical system of the eye to a wavefront aberrometer. So these things are highly sensitive, but totally non-specific. So this deviation that we're seeing here in the focuses could be caused by, a deviation in the crystalline lens, in the front of the crystalline lens, the back of the crystalline lens, the front of the cornea, the back of the cornea. We don't know. All we know is that there's deviation there. Now, in this case, though, this we know from the topography that this is a patient with keratoconus. But what we're going to do here is we're going to show you these are the raw sensor images. So you can see on the normal eye, those spots are relatively homogeneous. You can see that the points are about the same size. They have about the same spacing. It's about the same clarity all the way through the central portion here, whereas you see the variability in the keratoconic eye. Some of these points are in focus, some of them are blurry, some of them are out of focus, some of them are spaced out, some of them are squished together, all of those sorts of factors. Now, what we can do with that data, kind of almost think of that as like the raw images from, a placido in a way, right? It's just looking at the raw sensor images. But what we can do with those raw sensor images is by running simple algorithms on this, we can turn those into heat maps, right? So we can see on the left, we can see homogeneous color across this, indicating that there's not much variation. Whereas on the right-hand side, we can see that there's a big amount of change in that color scale, indicating that there is an area of deviation and an area of increased deviation. And we can see that there are areas of increased deviation around it in the blue area. What we can also do is we can quantify the individual aberrations. So just like we were talking about coma or trefoil or spherical aberration, we can break those down too in the exact Zernike polynomials and measure the magnitude of those coefficients. We can also show this in a point spread function. So all of these are things that we can do with a wavefront aberrometer. Now, when we want to compare this data or quantify this data, one of the easiest ways to do this is with something called RMS, or the root mean squared. Basically, this is a conglomerate number of all the aberrations that are present for an individual to give us a single value of this, right? So essentially, if you have a higher RMS value, you generally have more aberrations. If you have a lower RMS value, you have less aberrations, right? This is just a easy way of quantifying things. Now, when we kind of use a rule of thumb, what's a normal amount of aberrations for an individual? Well, that goes back to kind of that chart that we showed you earlier. But in general, we kind of use the rule of thumb of around zero point 0.3 to zero point 0.4 is kind of that normal average area. When we get above that area, we get suspicious that there is something going on in the optical system of that eye that is causing higher order aberrations, right? Now, if we want to compare aberrations, we need to make sure that the pupil sizes are matched, right? Because if I take the measurement in, dim lighting and have somebody who has a large pupil, and then we go ahead and take that same individual and turn on the lights and then take a measurement and we've shrunk down their pupil, we know that we're going to have less aberrations just based on that. So what we need to do is make sure that the pupil sizes are matched. Now, the cool thing about the softwares that exist for many of these aberrometers is they can automatically size down to a certain diameter for you to be able to make consistent measurements that are comparable. So these ones actually happen to be of the same individual wearing a wavefront guided lens in the second image over here. So this is their normal scleral lens. This is their wavefront guided scleral lens. And we can compare those numbers because those pupils are matched at 6.3 millimeters, right? So this is a direct comparison of the improvements that we're getting with the wavefront guided optics. So why would we use wavefront guided scleral lenses? Well, we know that the standard scleral lens optics are spherical or toric, and we can look at these by taking topography over the top of the lens. We can see the profile of those optics. But when we fit these on the individual, the common thing that you'll hear from these individuals after you've slaved away on getting a great fit of the lens, you've done the best that you can to be able to get them, 20/25 or 20/20 vision, and the patient will still say to you, hey, the vision still isn't sharp. The vision is still kind of blurry. And traditionally, that was the best that you could do. Now, why don't we get perfect optics when we use a scleral lens, right? We're masking the irregular cornea. Shouldn't that correct all the optics? Well, when we use rigid gas permeable lenses or scleral lenses, anything that's rigid, we're masking the anterior cornea, but what we're keeping internal aberrations. What we're also doing is because each one of those lenses has an optical profile on the front, if that lens is decentered, like you can see the scleral lens is here, compared to the line of sight, we're actually inducing aberrations as well. So decentration of the lens as well as internal aberrations from the posterior corneal surface or the crystalline lens itself will induce internal aberrations. So we know that on keratoconus, right, our anterior irregularity is not as bad as our posterior irregularity. So what we're looking at is once we've masked the anterior cornea, our posterior corneal aberrations come through a little more. They come in at about 20% of, what the front surface would be, but they're still coming through to reduce that quality of vision. So this is the reason that we don't get perfect visual outcomes with rigid lenses. And the question is can we do better for our patients? Can we get them better qualities of vision? So what you're going to see here is the comparison between traditional optics and the wavefront guided scleral lens optics. So what you can see is when we use the wavefront guided optics, and this is really the key to improving the quality of vision for these individuals, you can see how much better the quality is of that vision. We can see on our point spread function, our point becomes much tighter. We can see that we can get much more clarity out of the letters as we go down the chart, and indeed even improve to be able to read to a more improved line. So when we look at the simulations here, we can simulate out what the visual quality would be as well. And you can see the simulations of the patient wearing the traditional scleral lens and the simulation of the patient wearing the wavefront guided scleral lens. And you can see just the big improvement in the quality of vision. And I know who I would want to be driven driven in the car with. So taking in a look here, one of the main questions that gets asked is how do wavefront guided scleral lens optics work? Well, they work under the concept of destructive interference. So basically, this is the same way that your noise canceling headphones work. What we're doing is in a noise canceling headphone, we're listening to ambient sound, and then we're playing the equal and opposite sound wave into the ear, and the two of those sound waves cancel each other out so that we get better clarity of the audio around us, right? Or excuse me, the audio that we're trying to listen to. We're doing almost exactly the same thing with a wavefront guided scleral lens, but we're doing it with light and the optics instead of doing it with sound. So basically what they do is the patient wears a traditional scleral lens with these fiducials on it, these little markers. And what we do is we take our image over the top of the eye while wearing the scleral lens. These fiducials help us know where the lens is in relationship to the line of sight for that individual so that we can put the optics in the exact perfect spot. What we do here is we put these individuals into a windowless room without any lights on and then take our scans so that we can get the maximum size physiologic pupil that we can possibly obtain, the largest non-pharmacologically dilated pupil. In some individuals, if you just have a very well-lit clinic and you just cannot control the light, you may need to dilate the individual to be able to get a large enough pupil. That all said, once you get the largest pupil possible, you'll go ahead and you'll capture that image or that aberrometry through the whole optical system with the lens being worn. So you'll get your total higher order aberration with the lens being worn. What we'll do then is in the lab, we'll invert that data. so that we can create our disruptive interference pattern. And then we'll manufacture that into the optic of the lens at the decentration and rotation that was calculated based off of the location of the lens. And then when the patient wears the wavefront guided optic, we'll then have the destructive interference going because we're adding to it the inverted data. And then what we do is we reduce the total higher order aberrations when that wavefront guided lens is worn. So that's the process of this. Basically, measure what's there, create equal and opposite, and the two come together to cancel each other out and give us a better quality of vision. Now, this has been around as a concept for a very long time. The first patents on this were filed in 2002, issued in 2005. The first publications on using scleral lenses with wavefront guided optics were in 2013. And what those showed were a reduction of anywhere from about 43 to 66% reduction of higher order higher order aberrations, which corresponded to about a 1 to 2 line visual acuity improvement. Now, simple concept, but it was difficult to execute in clinical practice. We actually used these principles to be able to create wavefront guided lenses for ourselves back in like 2017. The problem was is that it was extremely time consuming. We were guessing at a lot of different things, and the outcomes were very poor. Only about 1 out of 10 that we were doing on our own would actually end up with a reduction in their aberrations. Now, come 2020, Ovitz came out with the X-Wave system, which is basically a system fully developed uh, to correct the higher order aberrations in scleral lens patients. So what we were doing, was previously jailbreaking devices, trying to use that data, doing hand calculations, sending that information over to the laboratory to try and get them to cut it if they could. Now it's a streamlined system. Basically, they have the Aberrometer, the software. All you do is take the scan, click the submit button, and it gets sent over to the laboratory, and the whole system is streamlined. You just receive a lens. Basically, your only additional step is taking the scan. So do the Ovitz wavefront guided optics work? Well, here are a couple of the retrospectives that we've done. These have been published either at, ARVO, American Academy of Optometry, or Global Specialty Lens Symposium. But basically, what we were seeing was in all situations, whether these were keratoconic eyes with intacs, or penetrating keratoplasties, all of these individuals experience about 1.5 lines of visual acuity improvement and about a 55% reduction in higher order aberrations. It's pretty consistent around, throughout populations. The question is always, do patients appreciate the difference, right? Because having clinical significance is really what's most important. Having statistical significance is great and all, but do patients actually appreciate this? Well, I'm going to give you a few cases here, and these are going to be really impactful because it's kind of an understanding of this. And these aren't your typical patients that we're going to go through right now. These are patients that were kind of atypical patients that had really great outcomes when I thought, maybe this patient might not have that great of an outcome, right? So this is a patient who had minor irregular astigmatism after a herpetic keratitis and the resulting scarring. So you can see that slight irregularity on the right eye. What the patient is telling me is this streaking is driving me crazy. And the right eye is 20/20 minus best corrected, and the left eye 20/20 with spectacles. With scleral lenses, I go ahead and fit him in these, and he says, I don't see the difference. It might even be worse. Still 20/20 minus in the right eye, 20/20 in the left eye. And you can see in the images below on the left side here and the left side here, you can see his point spread function. You can see how spread out the excuse me, the aberration is on the right eye here. What we then do is do the Ovitz optics for HOA reduction, and his response to this is the best he's ever seen. And you can see in the point spread functions over on the right images here, you can see how much we've improved and tightened up that point spread function, and we've been able to improve his visual quality down to 2015. So you can see we got about a 50% reduction on that right eye. On that left eye, which is a normal eye, we still got a small reduction in the aberrations, but you can see it just kind of tightened up the point spread function and improved his quality of vision. He's very happy with that. This one is an individual who is post LASIK, comes in, he's 2015 in both eyes, but he's telling me the glare and halos are so bad I can't drive at night, right? So what I do here is I go ahead and I fit the individual with a scleral lens, and he tells me this isn't any better. And in fact, his vision is a little worse. He's 2020 and 2025. What you can see here is this is his uncorrected or unaided vision, bare eye, on the left-hand sides. And this over here is with the standard scleral lens. You can see there's almost no difference in the amount of spherical aberration that's coming through for this individual. Now, when we get to the wavefront guided scleral lens, he goes, "Thank you so much. This is so much better." What you're seeing is over here, you can see how much more homogeneous the outcome is and how much of that spherical aberration we were able to actually eliminate. This individual ended up with about a 75% reduction in the aberrations, still maintained 2015, but you can see how that improvement in the aberrations was able to improve his quality of vision and actually improve his ability to drive at night and make him much more comfortable and happy with the visual quality. The next one was actually very interesting. So this was a post penetrating keratoplasty patient, had penetrating keratoplasty on both eyes, but was functionally monocular because they had an intraoperative choroidal hemorrhage on the right eye and lost vision there. On the left eye, with a standard scleral lens, we're able to get him to about 20/25, but the patient asked, is there anything that can make my vision better at nighttime? So what we did here was we did the wavefront guided optics to reduce the higher order aberrations. And what you can see here is we got about a 40% reduction on this, but the patient improved by about 2 lines of visual acuity. And the response from this patient was so impactful. They told me, "I feel safer." I feel like that can't be underemphasized, that not only are these, improving quality of vision, but they're improving confidence in doing, tasks of daily living. So this is something that was very, very impactful to me and more of a reason to offer these to our patients. Now, what we
Dr.
did
John,
here,
Dr. John, I'm sorry to
yeah, go
interrupt.
ahead.
Yeah, and this is happening with a lot of patients worldwide. So we get a lot of doctors from Palestine, a lot of doctors from Turkey, from Oman,
Mhm.
from Saudi Arabia, and they report the same issue. They try two, three scleral lenses, and they still get HOAs. So we get a lot of pentacams and a lot of other aberrometry readings, but
Yeah.
it's present. We see it a lot in scleral lens patients. You bring them down from 2400 to 2030 or 2025, but the patient still reports halos at night or poor
Exactly.
vision. So that's exactly what a lot of our doctors that are joining that joined this meeting are reporting, dear John.
Yes, yeah, common sort of, complaint from patients, right? And that's always, it's a source of frustration for the practitioner too, because, many practitioners go, "Look, I don't know what else to do to help you out," right? You're kind of stuck. So, this is really the way. This is how you can help these patients improve even further. So this was a study that we published in Eye and Contact Lens last year. But basically, what it was doing was looking at the visual improvement in wavefront guided scleral lenses for irregular corneal astigmatism. So this was a prospective crossover study where we took patients and we made them wear a wavefront guided scleral lens, the Ovitz wavefront guided scleral lens, and for 4 weeks. And then we crossed it over and made them wear a traditional optic scleral lens. Now, it was randomized, it was double blind. We didn't know what they were getting at what time. Um, the results, though, was that with the wavefront guided lens, we saw again around a 55% reduction in aberrations. But the thing that was very important on this was all eyes showed a reduction in aberration from 18% up to 83%. So even eyes that, the other thing that was very important in this study, we didn't eliminate eyes that had some level of opacity, right? So we allowed eyes that had some corneal scarring. We allowed eyes that had some cataract into this. We didn't eliminate them. And the only time that, we eliminated patients was if it was such a level that it was surgical, right? So they needed cataract surgery or they needed a PK, right? So for these individuals, this was really impactful data, right? Everybody improved in their aberrations. What we also saw was that there was about a line and a half improvement in visual acuity. Now, the thing that was interesting about this was about 71% of individuals showed 1 line or greater of visual acuity, up to a max of about 4 lines in improvement. 26% showed no improvement in visual acuity, and 3% showed 1 line of reduction. Now, that 26% that showed no improvement in visual acuity, that by and large was patients that were already 20/20 with their lens. But those individuals, based on the data set right or the data point right above that, all of them experienced a reduction in the aberrations. So when we asked, as part of this study, we said we had a subjective survey in it where they scored, the quality of vision with one and then scored the quality of vision with the other. And then we asked them at the very end, which lens did you prefer, lens A or lens B? Out of the entire data set, 17 out of 18 subjects preferred the wavefront guided optics. And if you ask them specifically about their distance visual acuity, 18 out of 18 preferred the wavefront guided lens. The one individual who didn't prefer the wavefront guided lens was an individual who was presbyopic in their, I believe, mid 60s or so. And their predominant aberration in their traditional lens was actually spherical aberration. So when we corrected their higher order aberrations, we eliminated their spherical aberration, which then reduced their near range. Now, the of the presbyopic group, though, and we kind of did this as a post hoc look, what we found was the individuals who were presbyopic, um, there was about half of these individuals were actually presbyopic. So, you're looking at a huge amount of individuals that really preferred the quality of vision overall. So, I'd say that that one individual was more of an outlier than what we saw, in the general population. But patients really do appreciate these optics. So one of the things is, kind of what else do we know about wavefront guided scleral lenses today? And what do we want to know about them, right? We want to know a few different things, right? So how important is movement, stability, alignment of these lenses? Well, we know that we need nearly perfect stability, right? So you need to be able to lock this lens into place on the eye. So this is where your toric haptics, your quadrant specific haptics, or your freeform haptics on the backside of your lenses come in. Because if you can get that lens to fit very well on the eye, it's going to stay rotationally in the same position. It's also going to stay in the same lateral position as well. So Does misalignment affect this? Yes. If lenses are misaligned, from their position, you'll have a substantial reduction in vision. How much movement tolerance do you have on the lens? About zero point 0.3 of a millimeter or about zero point 0.6, or excuse me, about 6 degrees of rotation. And when I say that, that is a very, very small amount of movement for these lenses. So really, it puts the onus on us to have much better fitting lenses for these individuals because we know that scleral lenses can be successful with having some movement with them. But for wavefront guided optics, they need to have virtually no movement at all to be successful. So keep that in mind when you're fitting patients like this. How about wear and tear? Do these optics last over time? Yes, we find that in a study that was done by Marsak's group, um, that cleaning a lens over a year-long period of time does not clinically change the aberrations for an individual. Coatings wise, are coatings like tangible hydropeg going to be something that changes the optics? These are clinically insignificant to the visual outcomes for the individual. Now, obviously, wetting of the front surface of the lens still matters, just like it does in a traditional optic lens. So, obviously, having a lens that wets is still very important, but adding a coating like Hydropeg is not going to affect the performance of the wavefront guided optic itself. So one of the questions that gets asked, because there's a little bit of, a misconception out there and a little misunderstanding with, eccentricity control and wavefront guided optics. So what is eccentricity control and how is it different from wavefront guided optics? So asphericity, eccentricity, Q value, basically all of these are controlling the same sort of concept here, which is how the periphery of a lens focuses. And that's really shifting that peripheral light rays to create a better point of focus, right? So in spherical aberration, it's caused by a misalignment of those peripheral light rays, which causes kind of stretching of the focal point, which gives us more of this sort of halo-like effect, right? Now that can be good or bad depending on what the individual needs, right? If we give them just enough spherical aberration, we can improve your depth of focus. But if we give you too much spherical aberration, it degrades your quality of vision, right? So we can use, excuse me, aspheric lenses where we bend that peripheral light array more to be able to make that focal point much tighter, and then we can reduce the aberrations further, right? So when we're changing asphericity, right, like for instance on a Boston sight lens, right? This is the low eccentricity Boston sight lens. This is the high eccentricity Boston sight lens. So you can see how the peripheral power changes in these lenses, right? So what happens is that's what we're controlling with this. But what you'll notice is the center of the lens is over here and the center of the pupil is over here, right? So if it was perfectly lined up with the visual axis, if we're changing the eccentricity, all we're changing is the spherical aberration, right? So there's no customization to be able to control the coma or trefoil or anything like that. This is just another view of that using a tangential map so you can see that curvature change a little bit more easily. But, if we use different eccentricities, we can create different results, right? And the reason that we get these reductions in, coma in some of these is that because the lens is decentered, spherical aberration when it's decentered is essentially coma, right? But this is not controllable. What we did here was a trial and error process. This is the same patient with the same lens shape, with the same lens power. The only thing that we did was change the eccentricity. So this is the low eccentricity, the mid eccentricity, and the high eccentricity. And you can see how we can flip the aberrations around, right? Our vertical coma flip directions from the low to the high, but you can see our mid kind of gave us the best overall aspect, but none of this is customizable. It's a process of trial and error, and we haven't eliminated all of his coma and spherical aberration. We've just kind of dampened it a little bit, right? So it's not customized to the patient's individual higher order aberrations, and it's unguided. It's kind of just a guess and check for an individual. Now, when would I consider using eccentricity versus totally customized wavefront guided optics from Ovitz if I have access to both? Well, I think of it like this. If I had an unstable lens, right, a lens that was going to rotate or translate or move, I would probably try to get it the best I can by using eccentricity because I know that if the lens moves or rotates with the wavefront guided lens, that I'm going to reduce the quality of vision further. If, however, I have a stable lens, I'm going to use that to correct the residual aberration, right? Because I know that that lens is going to stay in the same spot. So now I can target each one of those individual aberrations to reduce them all and provide the patient with the best overall outcome. Now, the other thing is, and this is what we can talk about a little bit, or in a little bit, will be that not only can I reduce the aberrations, I can also induce aberrations to be able to correct for presbyopia, right? And put multifocals right where they need to be. Or I can actually do a combination. I can reduce the aberrations that are present and then add back in only the spherical aberration that I want to be able to give them essentially the best multifocal that they will get. So, in general, in clinic, how do I use Ovitz? What I do is during my fitting, I'll use it as a screening process. So basically, I'll put a lens on, I'll go ahead and take my wavefront aberrometry with the Ovitz, and then I can see all the aberrations present. That's how I'll kind of judge, are you a good candidate or are you not, right? So I'll look at what their RMS value is, kind of what their pupil diameter is, and then based on that, what we'll do is we'll go ahead and discuss the findings with the patient. So the great part about this is Ovitz makes it actually very simple for you to discuss with the patient on this, right? So what I do is I go, look, we want to see that the majority of your aberrations kind of fall within these green lines here, right? That's going to show us kind of what the average individual sees. You can see this red bar here. That's telling us that you have a aberration that's severe. And that's what we're going to look to kind of knock down so it gets more into the blue areas. We want blue bars, not red bars, right? And then we can show them their simulated images here and their point spread functions. What this does is it really helps you connect with the patient because the patient, may have seen, and if you look at the National Keratoconus Foundation's data that they recently, have shown, these patients have seen four, other practitioners before they saw you. And, trying to describe this to other practitioners who don't get it, if you can show them a simulation and say, hey, I totally understand what you're talking about. This is actually a simulation of how you see, they'll go, oh, wow, you get it. Like you understand what I'm saying when I'm talking about the quality of vision, and you can really connect with them. But this is also a great way to kind of, talk about the results as well, because you can show them, hey, that bar that was red before, that's now blue. And you can see how the point spread function got better and how the simulated E improved in its quality. Now, what do we want to know? These are kind of the things that, are kind of outstanding and can be areas of research that we can look at. Question is dilation better than just physiologic, right? So we don't know. My results where we didn't actually dilate anybody in that prospective study were pretty consistent with the studies that have been done previously where they did dilate them. The question is there a certain pupil size that will help us determine that a patient is a better candidate than another, right? Does somebody who has a much smaller scotopic pupil not benefit as much as somebody who has a very large scotopic pupil, right? Um, you know, is there a certain amount of higher order aberrations that somebody needs to be successful? What I found though is that, and you saw that in that herpetic case, even patients who have normal eyes and small amounts of aberrations still get improvements, and they still notice the difference. So, there may not be a minimum quantity of higher order aberrations that can be benefited. The other questions is, what happens with implants like, intracorneal ring segments, or, CTAC or CARES or IOLs. What are the implants, the limitations here? In our data with CTAC here, we see the same level of gains that we see with, the other conditions, right? So we see about a line and a half of visual acuity improvement, about a 55 to 60% reduction in aberrations. What happens with fluid reservoir fogging? So fogging behind the lens, surface wetting, what's the impact on the aberrometry from that? I do see a reduction in the performance if we have surface wetting issues, but reservoir fogging doesn't seem to impact the result as much. Now, the next question is personality, right? How does personality affect this? Do people who are, very laid back about their vision notice the change? Do people who are, super, intensely or hyper aware of their vision, think that this is not enough? We don't know yet. And then what's the impact of opacity in the cornea or the lens? How much is too much and what location matters the most? you know? So the question that always comes up is why isn't this perfect, right? If we can measure the aberrations and we can correct for those aberrations, why aren't we getting zero RMS? Why aren't we getting, perfect outcomes on this? Well, it's because it's a dynamic visual system. We have things that are going to change, right? The eye's going to move, the lids are going to blink, the tear film is going to change over the top of the lens. The pupil is going to change size. The lens thickness is going to change with accommodation. We know all of these variable factors are going to happen. So we can expect improvements, but it's not going to be perfect from situation to situation, but it's definitely going to be better than the traditional. So, what about scars and cataracts? Well, when I look at this, I always look at, where's the scar? Where is the cataract, right? So, if we have a dense corneal opacity, they really got to have that addressed, right? And that's a surgical problem. They're either getting a PTK, a super K, or going through a corneal transplant. On the opposite side, if we see, crystalline lens opacity, right, then that individual needs cataract surgery before we move forward. But how dense is too dense? We really don't know that yet. What I look at is when we get to, the spot quality, right? So what you can see here is these are all the spots on an individual without a cataract, right? And then you can see over on the side here, the spots on the left is an individual without a cataract. On the right is an individual with a cataract. And you can see how the spots aren't quite as crisply defined, right? So you can see how there's kind of this scatter around it, the speckling of that spot. So you can look at the spot quality, right? If we have a very clean spot, or at least a spot that's not kind of bleeding into the other spots, and we can clearly discern where those spots are, they can create a lens for that, right? Now, if we have, a very dense wavefront aberrometer, sometimes it ends up with totally missing data versus a wavefront spot pattern where it's a little more spaced out, where we can kind of go around some of that scarring or, some of like a dense focal cataract, right? So we can still produce this. The wavefront sensor on the ovits, I kind of consider it the Goldilocks amount because you can still get a really good result even when there is some level of scarring or cataract because you're not missing the data in that area. So kind of imagine, scatter is essentially how tight those spots are. This is just another demonstration of this. This was from a device called the ocular, excuse me, gosh, I'm going to totally forget the name of it right now, but the HD analyzer, that was the name of it. But basically, what you're seeing, so this is one where this was actually a problem. You can see this patient had a pretty dense scar, and you can see that we can't really super discern where all the spots are on this one. So this individual needed to have, a DALK before we could get a good, result. So how else can we use Ovitz wavefront guided optics, right? And the reason that I've been using wavefront guided optics instead of higher order aberration correcting optics is that you don't just have to do higher order aberration correcting optics. You can add in spherical aberration or multifocals in exactly the place where you need them, right? One of the challenges with multifocal optics was always, are we getting the optics in the correct position, right? And there's been different ways that people try to solve this with online calculators or with, topography, measurements where we take a measurement of the lens on the eye and kind of say, oh, that's where the optic is, and here's, where our pupil is, and we should move it this direction, or with like hash marks on the lens. Um, when we do this with the Ovid system, because we have those fiducials on the lens, we know exactly where the lens is as far as, location on the eye in relationship to the line of sight. So we can put the optics directly where we need them. So this was actually just a normal eye patient with myopic astigmatism and presbyopia. So what I did was I fit this individual with a scleral lens, and you can see that we did the traditional lens, we added our wavefront guided optics on there, and then what we did was we layered on a multifocal to induce the spherical aberration. And when we induce that spherical aberration, you can see that we're getting almost pure spherical aberration for this individual. And you can see how perfectly centered that is to their line of sight. So this is really improving the quality of vision for these individuals and giving them excellent outcomes. So you can see here, we had an improvement, at near to 20/20 while maintaining 20/20 distance visual acuity. So you can see we can really get a great outcome for these individuals. Now, the other one that's very cool is when you start layering these things. So this is a keratoconic patient. You can clearly see that. What they were complaining of was, hey, I can't read anymore. And usually, we don't do multifocal optics on keratoconic patients because you're stacking up aberrations, right? You have their coma and trefoil that's coming through from their disease, and then you're adding spherical aberration on top of it. So now you're just adding more aberration. And in many cases, that just declines the quality of vision further, right? Well, what we can do with this is with the Ovid system, what we did was we take our measurements on the traditional lens, which you'll see on the left. In the middle, we correct them for reducing the higher order aberration. And then what we do as our final step is add back in spherical aberration in the spot where we want it. So we've wiped the negative aberrations and only added in the aberration that we want. And what we've been able to do is improve the quality of vision for this individual. So they went from being 20/20, 20/25 to being 20/15, 20/20 with this solution. So we can really improve the quality of life with these patients. And you can use this not just for reducing aberrations, but also inducing aberrations for the presbyopic population. So with that, I'll wrap it up and go ahead and take a little bit of questions for about the next 5 to 10 minutes.
Great, Dr. John. Amazing meeting. Okay, doctor. Dr. May Bakar is asking us, since severe dry disease causes dynamic high order aberration, HOAs, due to tear film instability. Can scleral lenses such as those using Ovid's technology effectively control these dynamic HOAs, or is it the technology currently limited to correcting structural HOAs that arise from stable optical surfaces like the cornea or the crystal lens?
Beautifully said right there. It can only correct the stable aberrations. Variable aberrations that are caused from, severe tear film abnormalities are not something that this is going to help correct. But I will say that for the baseline aberrations, right? So let's say you had somebody who had, has severe dry eye. Sorry, has severe dry eye, and you have them with a lens that is wetting, and you can get them at that moment, you can reduce their base level of higher order aberrations. But what's changing over time over the top of it with the dryness, that change in aberration won't be something that you would be able to correct. But you still could improve their base aberration from the stability of optics, and then you still have the variation that would happen later from the breakup of the tear film over time. But you're not going to be able to correct the breakup of tear film aberrations that are induced from that, those variable aberrations. Only the static aberrations.
Great. More questions are coming. My
Yeah.
dear friend, Dr. Niall Fernon from Trinidad and Tobago, he's a customer of Spectrum International. He's asking us, what is the cost of the lenses compared to a standard lens? For example, if a standard lens cost Y, how much would it cost for the patient using custom HOA? And I think, Dr. John, this question relates to me.
Yeah.
Dr. Niall, please contact us to find out how much the lenses are. Yes, there's a cost associated with custom HOA lenses, not only internationally, but also in the United States.
Yep.
Uh, Dr. John, how much do you charge patients for custom HOA?
Yeah, so generally when we look at this, so the cost to us is about double um what the base lens costs. So we do double it for the patient too, because we need to be able to, make make it make sense for, providing it as a service. So yeah, it's double the cost for us, that's double the cost for the patient too.
And Dr. Nile, a lot of our doctors, we sold a lot of Ovid's now. In the past 2 months, we sold a lot of Ovid's instruments into Latin America. And what our customers are now charging the patient per lens is between 600 to 700 additional US dollars to the patient. But please remember, these patients are patients that you brought down from 2,400, you brought them down to 2030, but they still tell you, hey, I cannot see at night, I still see halos. So when you see or when you do this improvement of vision to them, they will pay the cost for a custom HOA lens. That's my
Yeah,
personal experience.
yeah, and I'll tell you the thing about it, and this is where I think patients, um, or rather practitioners, some may have hesitancy in this. Um, do I adopt this technology? Are patients really going to appreciate the difference? That study should give you a pretty good idea of this, and it's what I see clinically every day. We've done hundreds of these cases at this point, and what you'll see is that these individuals, they all improve, and they're all very happy with the improvements. All of them, if you were to give them the choice between, the base lens and the higher order aberration correcting lens, they're all choosing the higher order aberration correcting lens. So it is high impact, and it works.
Yes. Thank you. Dr. John, I don't know if you know this, but do you know that we had Abe Vanderwerp from the Netherlands joining in the conference? He's actually live and listening to you at the moment.
Hi, Abe.
So can you believe that Abe and I were having dinner and he's like, "Hey, do you want to know where Cerny lived? Look at his house." So he showed me his house in the Netherlands. That was
Oh,
crazy.
gorgeous.
Yeah,
Yeah.
beautiful.
Awesome stuff.
We need to have a beer together in that GSLS. Okay,
Yeah,
so
for sure.
Dr. Nora Alomar from the Middle East is asking us, in terms of improving QOV, can you make a comparison between correcting the HOA with WFGSL and top guided laser to resurface the irregular cornea, then fitting the patient with scleral lens?
So we've done a lot of patients who are, post topo guided PRK with wavefront guided lenses. I will tell you that because you're changing the aberration profile, so there, let me answer this a couple different ways, right? If I take a patient who, let's say, has keratoconus and I fit them in a scleral lens, and then I turn that scleral lens into a wavefront guided scleral lens, and then the patient undergoes topography guided PRK. If I use that same wavefront guided scleral lens as before, the vision will be bad because those aberrations that were set up on that original lens were set up for the original cornea. Now that we've changed the optics of the cornea, we need to change the optics on the lens to match that. So essentially what we would do is I would call the lab, have them wipe the optics, and we'd go back to a base lens profile. I'd retake my measurements and then create a new wavefront guided scleral lens for that individual to now take on what the new shape of the cornea is and the new optical need is. Hopefully that helps to answer that question. Um, but yeah, hopefully that helps to answer the question.
Okay, my dear friend Kyriakos Telematsi from Cyprus is asking us, what about the front fogging with oil after 1 or 2 months when you finish the HOA scleral lenses?
Yeah. So front surface kind of malady from tear film issues are not something that is going to be corrected by this. As long as they can, clear the lens or you can treat the tear film abnormality or what have you and get back to that stable baseline, you won't need to change your aberration profile for them. It's just getting their surface or their tear quality stabilized so that you're no longer having those issues. But yeah, anything that's like, mucusy, oily, proteinaceous, anything like that that sticks to the front surface of the lens, it's going to degrade the quality of vision just like it would on a traditional scleral lens. So yeah.
Okay. My dear friend, Dr. Naji Bazil from Lebanon, not sure if I understand the process from a clinical standpoint.
Yeah.
We use a regular scleral lens as trial, and then how we translate this into a custom HOA. And let me answer this first, Dr. John. Dr. Naji, the current scleral lenses that you are fitting right now are not available with custom HOA. So Excel Contacts, the Atlantis lens, unfortunately, they have not launched a HOA custom scleral lens yet. The scleral lenses that you do have available in Lebanon at the moment are Maxim 3D, Smart Lens Pro, and Boston Sight. I don't know of any other scleral lens available with custom HOA in Lebanon. But to give you a little bit of perspective, so what you do if you were to fit Boston Sight, Maxim 3D, or Smart Lens Pro, what you will do is you would fit that patient with a regular trial lens. Then you will finalize the fitting. I don't know if it's going to take you 1 or 2 exchanges. Once that lens is stable, and you think the patient can benefit from HOA custom lenses, then we will send you the same lens, same prescription, same base curve, same diameter, same sagittal height, and we will send you the same lens with the dotted pattern dots that Dr. John showed you in his presentation. Once you receive the lens, you will read it with the Ovid's aberrometer, and we will get that reading, and we will design a custom HOA lens. John, please let me know if I missed anything.
No, that's perfect. Basically, when I like to simplify this, and I should definitely put that, that's a good note for changing adding a slide to this. But basically, I like to think of this as two parts, right? You do exactly what you normally do to get to a finalized lens. Once you're at that finalized lens, then you call the lab, add the dots, and then you start the OVIDS process, right? So it's basically two parts, right? Fit your lens like you normally do, finalize it, then start the OVIDS process, add the dots, take your measurement, and then get your wavefront guided lens.
That's it. That was very much so what the process looks like, Dr. John. Thank you so much.
Yeah,
Okay,
not a problem.
another question, and we are only going to take two or three more questions, Dr. John, so you can go to lunch.
Okay. Well, I start patients now
Oh,
for the
okay,
next
okay.
8 hours.
So two
So
more questions.
yeah.
Dr. Bob, his name is Ibrahim Abu Taha. He's from Lebanon as well. Since regular lens give uh, BCVA, how do we know how much improvement are we going to achieve in terms of visual acuity ahead of
Ah.
ordering the lens?
Yeah, so when I go over this with patients, this is exactly what I say in the lane, which is, once we get to a finalized fit, I'm going to evaluate what your vision is. And at that time, I'll determine whether or not we can improve the vision further. In general, I'm going to add glare correcting optics, is what I say, right? Now, it's going to be better. It's not going to be perfect, but it's going to be improved from what you see now, right? And that may mean that you see maybe a line or two better on the chart, but what it's really going to do for you is that it's going to crisp up the vision and reduce the glare and smear and doubling that you see so that you get a better quality of vision. Once they understand that it's all about the quality of vision, they've all bought into that, right? Everybody understands, oh, I want to be able to see things better. They don't care. You could tell them, oh, you're going to see 6 lines better on the chart, a line better on the chart. You may not see better on the chart. Is they need to understand that it's not really about the letters on the chart. It's about the quality of the vision that you're getting. And that's where I really spend my time on it. Look, in on average, we see about a 50% improvement in your quality of vision. Now, what that means to you, it's just going to look a little clearer. And that's what we discuss with it. It's not you know, because this is where I think practitioners get in trouble with offering this technology is over promising. Oh, it's going to give it's going to be, perfect vision. No, better, not perfect. It's going to improve quality of vision. And once you kind of lay that out, most patients are on board with it, and then you move forward from that. Predicting it right now, very difficult. We're trying to look at that, but we haven't made much headway as far as, these individuals are definitely going to do better. What I find is typically the worse you are, the better the gain. That's kind of it, as far as like lines of vision are concerned. As far as, reduction of aberration, that seems to be pretty consistent no matter what. So I feel pretty confident telling patients we, on average, see about a 50% reduction in aberration. And based on our research, the vast majority of patients appreciate the improvement in vision.
Three more questions, I'll let you go.
Yeah.
Dr. David Berkol, dear friend of ours as well from Israel, a really good fitter. Are Ovid's guided lenses a preferred solution to eye print design lenses?
So kind of two, apples and oranges, if you will. The iPrint lens is a great platform that actually can have the wavefront guided optics added to it. In fact, that was one of the early, kind of test platforms that we did. But yeah, you can successfully add these optics to a an eye print lens. Yeah.
Awesome. Dr. Prasad Sawat, what is your experience while fitting post-hydrop keratoconus patient scar formation cases? Does these HOA scleral lenses help?
Yes, actually. And that's actually kind of the interesting thing about this. It depends on where the scar location is and how dense the scar is, right? A peripheral, let's say your line of sight is here and your scar is over here, and the densest part of the scar is over here. You have maybe some flare of the scar that goes into the pupil axis. As long as you can measure through it, they can make a lens based off of it, and it will improve the quality of vision for those individuals. Now, you may not get, a 70% or 60% reduction. You may get a 20 to 40% reduction, but that's still an improvement. For those patients, it still may be, beneficial to them. So it's interesting, I'll have patients that have, scars, cataracts, other things like that. They still get, a 30% improvement, and they'll tell me, hey, this is way better, and I'm going, it's only like 20 or 30%. But, you can't judge an individual's experience, just based on statistics, right? So, it's really impactful even at that level. Now, let's change the location of that scar or cataract, right? Let's say the dense portion is dead center, right in the visual axis. That patient probably not going to do so hot because you're going to be missing that data right in the middle. So it really comes down to, when you look at your spot diagram, is the data there or is the data missing? If the data is totally missing, probably not a good candidate. But the aberrometer is going to tell you, the data is missing anyway, right? So you'll know right away from that. The thing that I would do though is if I'm not sure, I submit the scan anyway to Ovitz and let them tell me if they can make a lens out of it.
That is a great add-on, Dr. John. Yes, Ovitz has consultants. You can consult on the lenses before ordering them, or you can also contact us in order to help you. So you have a lot of people, a lot of ODs, and a lot of consultants ready to support your fittings. Last
Yes.
question, and then I'll let you go. Do the wavefront guided lens affect the massively high RMS values that maybe cause a distortion in objects and shapes?
So it yes, we can do like I actually had a patient yesterday that had 2.5 microns of total RMS while wearing the scleral lens, and the wavefront guided optics from Ovitz were able to bring that all the way down to zero point 0.4. So, you can really get massive improvements in these higher order aberration. Now, there are certain things that you're not going to be able to correct, right? Scatter from scars, right? That will still be there. Like RK scars are a really tough one, right? We can measure around it, but those scars are pretty dense, and if they're extending into the visual axis, we'll get some level of improvement for them, but we can't measure through the scars. And what we can't measure, we can't correct, right? So those are kind of the limitations to it. Scatter is really not something that you can correct. So, differentiate, is it actually aberration or is it scatter? That's an important part of this. Now, one other thing that I do want to add is that visual outcomes, right? When you get when you get one of these lenses back, take your aberrometry over the top of that wavefront guided lens to understand what's the visual outcome for it. In some of these, there's actually the opportunity to continue to improve. So, they'll have an option on the Ovitz ordering system where you'll click, I can add an over refraction, I can add an overfraction and aberration modification if there's a major improvement that can be done, or I can ask them to do, a aberration improvement, even if I'm only expecting a minor improvement. So it's very, very cool in the system. So you can really get into this. Like if I have somebody and let's say they only got a 30% improvement, I'll send, hey, even if there's a minor improvement, make an update to it. And by and large, most of these individuals, as long as it's not scarring base that's kind of limiting the data that they're getting, they'll go back and they may revise it. And I might get an extra 10 or 20 or 30% for that individual. And, they'll get an even more improved quality of vision. So it's something that you can look at doing, and it's very cool, a very cool system. You guys will have a lot of fun with learning this, and more importantly than the fun of, of doing it, it's the satisfaction of actually being able to do something to help these patients.
Changing lives.
Yeah, it's a huge, huge impact. And, you may think, hey, it's only a line, but it's a line plus the quality of vision plus the quality of life. It's hugely impactful for these individuals. So, adopt it and have, you know, really just enjoy the opportunity to help these individuals.
Dr. John, thank you so much. Please don't leave. If you're listening to this meeting, please don't leave. We have a very important announcement. But John, I just wanted to thank you and give you a huge hug from the entire Middle East world. You had over 1,000 practitioners joining. You had over 30 countries. So I'm very pleased and very happy that we were able to share your knowledge, your experience, and expertise with the world. Thank you so much. I'll see you at
Awesome.
GSLS, and I want to thank Ovitz for this wonderful opportunity.
Excellent. All right, guys, take care.
Thank you, Dr. John. Okay, so we have partnered up with the iHeard, which is one of the one of the most prestigious educational platforms for optometrists and ophthalmologists around the world. And they're going to be launching a scleral class exclusively to the Middle East next year in 2026. So I'm going to leave you with Ms. Liliana Galeano, and she is the CEO and president of the iHeard, and it's only a 2-minute introduction of what the iHeard is going to be doing in your market. You cannot miss these classes. This is going to be something incredibly good for you and your patients. Liliana,
Hello, can you hear me now?
I can hear you loud and clear. Yes.
Yeah, thank you. Thank you so much for giving me this time to talk and to connect with you all. As Felipe says, I'm talking in behalf of the iHeard, the digital learning community platform for all of you that want to update your knowledge and skills. We have already 1,200 doctors with us in our digital learning experiences. And now for 2026, we want to launch with you our advanced course in scleral lenses. So if you want to become an indisputable reference in scleral lens adaptation, training yourself to solve the most complex cases, you want to be part of this experience. What we do is that we have the world elite instructors. As you see, as Dr. Gillies, as A. Butterworth, these are the kind of KOLs that we have in our learning experiences. And we are going to give you an advanced level content. Is as we have these webinars, but you will have them in an organized platform. You are going to have them alive, and we are going to give you a structured and progressive content to make sure you are going to learn the secure path to be a referent in scleral lenses. We have a proven methodology, we have interactive questions, and we have exclusive support. You are going to have a group of colleagues that are in the same path of you, like you, of improve yourself, improve your skills, and improve your career. And we are going to share with you in this group all the exercises, all the ebooks and notes that we have related with this course. We also are using the latest trends in digital learning experiences. So what are the modules are in this course? We are going to have the scleral in-depth, advanced mapping, and bioengineering. We have module 2, empirical treating and advanced design protocols. We have the complication mastery, In advanced ocular physiology management, we have ocular surface, chronic dry eye, and scleral lens integration, special cases and custom scleral lens applications. And we are going to close with two modules devoted to elite practice and advanced profitability, the business of scleral. So as we said before, we have in these kind of courses, KOs as Melissa Barnett, Ellis Kramer, Ed Van de Werf, that we are going to give you the content. Normal, these courses are valued in $3,000 because it's a learning experience where you are going to talk directly with these KOLs. You are going to have a direct Q&A. You have ebooks from themselves. You are going to have a support group where they are going to learn in the pace you are. But now that we are launching this with you, nobody knows about this course. Is we have the opportunity to join Spectrum International in this webinar. We wanted to give this prize only for these people that are connected right now. You have 2 hours to decide yourself if you want to be part of this learning experience. So normally this course is going to be $600 next year. But as you are connected today with us and listening to me, you can be in this learning experience in $247. You are going to get the 7 content modules, access to the exclusive GI Heart community where colleagues from all over the world are going to be talking in the same topics as you, demonstration of practical and current case studies, unlimited access to our platform where you are going to repeat all modules, and this platform is designed for a very good learning experience. You are going to have the module available on technologies and products, ebooks available, structured templates, and you are going to update your knowledge. If you want to update, if you want to learn, if you want to be in the advanced level of fairness scleral lenses, so this is the experience for you. We have 50,000 doctors that have been in our webinars and our events, and we have a lot of people that have already done our courses, but this is our first time that we are opening this advanced scleral lens. We really, really, really appreciate if you want to contact us and ask everything that you want. So here are the number or the mail, or if you want, you can contact Spectrum as well, and we are going to tell you everything about this learning experience. Thank you, Felipe, and thank you all for being in this webinar and listening to me.
Thank you so much for joining this meeting. You're going to get this presentation. You're going to get the recording, of course. That presentation from Dr. John is going to be uploaded into our YouTube channel. Of course, we're going to be sending you brochures, information, and all the patient-guided marketing support that we have for OVIDs and for custom HOAs. And again, if you want next year to become a scleral lens master, do not miss the opportunity to learn from one of the best educational sites in the world, the iHeart. My customers in Latin America and the Caribbean have registered to multiple of their courses, and they can really help you. So if you're interested in learning more on how you can become a scleral lens master fitter, just send us an email or read this QR code or contact the iHeart directly. Thank you so much for joining. I know it's pretty late in the Middle East. Again, thank you. Over 30 countries live and over 1,000 people were listening to this awesome presentation. Incredible content, I hope. Thank you so much, doctors. You take care. Have a wonderful week. Bye-bye.
Thank you. Bye. Thank you.